Hello 8th graders, today we meet again in online learning SMPK Penabur. I hope all of us and all of our family are still in a good condition. After we have learned about Pascal principles at the previous meeting, today we will learn about Archimedes Principle. Basic competence for our topic today is 3.8. Describe the pressure and its application in everyday life, including blood pressure, osmosis, and transport tissue capillaries in plants. Archimedes Principle. To understand about Archimedes Principle, firstly we will see the activity from the figure below. From the first figure, we see that weight of the object in the air, which is measured with spring balance, is 4 Newton. And from the second figure, we see that weight of the object in the liquid, which is measured with spring balance, is 1 Newton. From this figure, we can conclude that there is weight loss from the object. Because of that, we can get from this activity weight object loss equals weight object in the air minus weight object in liquid. From the figure, we can see that after the object immersed into the liquid flows from the eureka can into the glass. And weight of the liquid in the glass can be seen on the weight balance is 3 newtons. In here, we can understand that magnitude weight object loss is equals with weight liquid displaced from eureka can. So, this formula, weight loss equals weight object in the air minus weight object in liquid, can be substituted with weight displaced liquid equals weight object in the air minus weight object in the liquid. While liquid in the eureka can be displaced to the glass, while object is immersed into the liquid. Because while object which has weight W is immersed into the liquid, weight object W will press the liquid downward. Hence, the liquid will push the object upward with force Fa. Fa is buoyancy force or Archimedes force, and this force makes fluids flow to the glass. From this, we can conclude that weight of liquid displaced is equals with buoyancy force Fa. So, this formula, weight displaced liquid equals weight object in the air minus weight object in liquid, can be substituted with Fa equals weight object in the air minus weight object in liquid. From the activity at the previous slide, so Archimedes' principle states when an object is totally or partially immersed in a liquid, the object experiences an upward force that equal to the weight of displaced liquid by the upward force. So, Fa equals weight of displaced liquid. And we know that weight of displaced liquid equals mass of displaced liquid times acceleration of gravity. Because mass of displaced liquid is equals with density of liquid times volume of displaced liquid that equals with volume object immersed, so magnitude of buoyancy force Fa can be written as Fa equals density of liquid times acceleration of gravity g times volume object immersed. Notes: Fa, buoyancy force or upward force or Archimedes force, has unit Newton, and density of liquid has unit kilogram per meter cube. Volume object immersed has unit meter cube, and g, acceleration of gravity, has unit meter per second square. To get more understanding about Archimedes principle, let's see example 1. An object in air has weight 0.7 Newton and its weight in water is 0.4 Newton. If density of water 1000 kg per meter cube and g equals 10 meter per second square, determine A, buoyancy force, B, volume object immersed. Given weight object in the air equals 0.7 Newton, weight object in water equals 0.4 Newton, density of water equals 1000 kg per meter cube, and acceleration of gravity equals 10 meter per second square. From the problems, ask Fa, buoyancy force, and volume object immersed. Answer A. Fa equals weight object in the air minus weight object in water. So, Fa equals 0.7 Newton minus 0.4 Newton. So, we can get Fa equals 0.3 Newtons. And for question B, Fa equals density of liquid times acceleration of gravity times volume object immersed. So 0.3 Newton equals 1000 kg per meter cube times 10 meter per second square times volume object immersed. So we can get volume object immersed equals 0.00030 meter cube. Or we can write volume object immersed equals 30 centimeter cube. Archimedes principle can explain three conditions object in liquid, which are float, drift, and sink. The three condition object in liquid can be seen on the figure below. Firstly, we will discuss about flow. From the figure, we can see that the object in equilibrium condition, so that resultant force at y-axis equals 0. And on the object, there are two forces work on the object. So, resultant force at y-axis equals Fa minus weight object equals 0. So, from this we can get the requirements for float is Fa equals weight object. Because we know that Fa equals density liquid times G times volume object immersed, and weight object equals mass object times acceleration of gravity, that mass object equals density object times volume object. So Fa equals weight object can be substitute with density liquid times G times volume immersed object equals density object times G times volume object. Because magnitude G at both sides is the same, so we can erase G at both sides. And now we get density liquid times volume immersed object equals density object times volume object. While floating, volume object is bigger than volume object immersed in liquid. So in here we get that density of liquid is bigger than density object. The second condition is drift. From the figure at the previous slide, while object in drift condition, we see that the object in equilibrium condition. So, resultant force at y-axis equals 0. And there are two forces that work on the object. So, resultant force at y-axis equals Fa minus weight object equals 0. Hence, we can get requirements for drift is Fa equals weight object. Formula Fa equals weight object we can write as density liquid times G times volume immersed object equals density object times G times volume object. Because magnitude G is the same at both sides, so we can erase G at both sides. And based on the figure, while drift or object immersed in liquid. So, volume displaced liquid equals volume object. Or we can say, while drift, volume object immersed equals with the volume object in the air. So, we can erase volume immersed object at the left side with volume object at the right side. So, finally, we can get relation for drift that density liquid equals density object. And the third condition is sink. From the figure, we can see that while sink, object located at the base of the container. This can happen because weight object is bigger than Fa, and this relation is the requirements for sink, that weight object is bigger than Fa. If we substitute weight object bigger than Fa with density object times G times volume object bigger than density liquid times G times volume immersed object, so in here that G can be erased at both sides because magnitude G is the same. And we must know, because while sink or object immersed in liquid. In here, we can say while sink, volume object immersed equals with the volume object in the air. So we can erase volume object at the left side and volume object immersed at the right side. And now we can get the relation for the sink that density object is bigger than density liquid. To get more understanding about the three conditions of object in liquid that can be explained by Archimedes Principle, let's see the two examples below. The first, we will see the example 2. Look at the figure and the table below. Based on the table above, so the correct substance 1, 2, 3, and 4 consecutively are answer. Based on the figure above, we can see that substance 4 is floating in liquid 3. It means density substance 4 is smaller than liquid 3. And liquid 3 located above liquid 2. It means density liquid 3 is smaller than density liquid 2. And the last, substance 1 sink in liquid 2. It means density substance 1 is bigger than density liquid 2. So, we can conclude that the correct substance 1, 2, 3, and 4 consecutively are aluminum, water, oil, and wood. Example 3. An object which has volume 0.2 meter cube immerse 40% in water. That density of water equals 1000 kg per meter cube, and G equals 10 meter per second square. Determine A. Upward force or buoyancy force. B. Density of the object. From the problems above, given volume object equals 0.2 meter cube, percent object immersed in water equals 40%, density of water equals 1000 kg per meter cube, and G equals 10 meter per second square. Ask Fa and density object. Answer. To answer question A, first we have to determine volume object immersed. That volume object immersed equals 0.2 meter cube times 40% equals 0.08 meter cube. And to determine Fa, we can use formula Fa equals density water times G times volume object immersed. So Fa equals 1000 kg per meter cube times 10 meter per second square times 0.08 meter cube. So Fa equals 800 kg meter per second square equals 800 Newton. And for the question B, because floating, so we can use the requirements for floating for the object, that Fa equals weight object. So 800 Newton equals density object times G times volume object. And 800 Newton equals density object times 10 meter per second square times 0.2 meter cube. So density object equals 800 Newton divided by 2 meter to the power of 4 over second square. So magnitude of density object equals 400 kg per meter cube. After we have understand about Archimedes principle, now we will learn about the application of Archimedes principle related with the condition object in liquid, which are float, drift, and sink. Here is the application of Archimedes principle. First is hydrometer. Hydrometer is an apparatus to measure density of the liquid. Second is pontoon bridge. The third is submarine. And the fourth is dockyard. In bahasa we call it as galangan kapal. And the fifth is ship. I think that's all our video for Archimedes principle today. I hope this video can enhance your understanding about Archimedes principle. God bless you.